Computers are used in various fields for different uses. They are categorized into 4 types based on their size, performance, and cost. Microcomputers. Microcomputers are smaller in size and capabilities. They are generally used in schools, offices, shops, etc. to do various types of jobs. They are the most popular and multi-purpose computers. These computers are cheapest as compared to mainframe computers, mini-computers, and supercomputers. Microcomputers are also called personal computers, PCs. Examples are desktops, laptops, and tablets. Desktops are kept on a desk and need electricity to work. Laptops and tablets can be carried along and work on chargeable batteries. Mini-computers. Mini-computers are more capable than microcomputers. They are faster and have more storage capacity than the microcomputers. These computers are used less these days. Examples are PDP-11, K202, etc. Mainframe computers. Mainframe computers are more capable computers. They are larger in size, faster, and quite expensive than mini-computers. They are mostly used by large organizations where large amount of data needs to stored, such as banks, railway stations, etc. Examples are ICL-39, IBM 4381, Hitachi Z80, IBM Z13, etc. Supercomputers. Supercomputers are the most powerful computers. They are very expensive. They are used in forecasting weather, controlling satellites, designing aircrafts, studying earthquakes, etc. Examples are Cray XMP, PACE, Titan, etc. The fastest supercomputer in the world is Sunway Taihu Lite, developed by China.
Handheld devices. A handheld computer is a computer that is held in a hand and can conveniently be stored in a pocket. It is used while holding it. Touchscreen is the primary method of input in such devices. Smartphones, smartwatches, gaming consoles are some examples of handheld devices. Smartphones. Smartphones are handheld devices that allow us to make or receive calls and send messages. They have an LCD flat screen and a touchscreen keyboard. These devices have features such as camera, gaming, video, and can connect to the internet also. Smartwatches. Smartwatches are wearable computing devices worn on a user's wrist. They offer functionality similar to those of a smartphone, like connecting to the internet, running mobile apps, making calls, etc. Gaming consoles. Gaming consoles are handheld devices that are used to play games at any time and any place. These devices are designed for interactive video game play and display. Embedded computers. An embedded computer is a small computer fixed inside a machine. It is a computer with specific instructions and requirements used as a part of any larger system. Just like an ordinary computer, embedded computer has the essential components: CPU, RAM, ROM, input devices, output devices, and a clock. Many devices today contain some sort of embedded computers, such as ATM machine, modern TV sets, digital cameras, CD players, motor vehicles, washing machines, microwaves, dishwashers, and also traffic lights.
Programming languages.
A program is a set of instructions, when executed, makes the computer work in a particular manner. To write computer programs, computer languages are used.
A program is written in a specific language called programming language. Computers do not understand any other language that we speak. They understand programs written in special languages. The process of designing, writing, and test a program is called programming. A person who writes a program is called a computer programmer. A programmer writes the program in one of the programming languages.
Computer languages can be categorized into two types. 1. Low-level languages. 2. High-level languages. Low-level languages. Machine language and assembly language are called low-level languages, LLL. Machine language. A computer can understand only special signals, which are represented by ones and zeros. These two digits are called binary digits. On state represents the binary digit 1 and off state represents the binary digit 0. The instructions in machine language are made of binary numbers. This makes the language suitable for the understanding of the computer, but more difficult to interpret and learn by the human programmer. Example is binary language. Assembly language. Assembly language was developed in 1950s. These languages use letters and symbols instead of binary digits. These are also known as mnemonics. But as computer cannot understand the instructions written in any machine-level code in other language, a translator is needed to convert the assembly language program to machine language. This translator is called assembler. Programs written in assembly-level languages are called assembly codes. High-level languages. The languages of above generations were machine-specific languages. The next step in the development of computer languages was high-level language, HLL, a language that is quite similar to English language and is simple as well as user-friendly. Advantages of high-level languages. Programs written in HLL are easier to understand and read. It is easier to debug a program in HLL. Programs written for one computer can run on different computer. Examples are Pascal, Fortran, Basic, COBOL, C, C++, and Java. Difference between low-level language and high-level language. Low-level language, difficult to write. High-level language, easier to write. Difficult to test or debug. Easier to test or debug. Processing speed is fast. Processing speed is slow. Modern high-level language. These languages are closer to human-like languages than the old high-level language. They are easier to learn and write. These programming languages are designed to reduce the overall time, effort, and cost of software development. These are also called fourth-generation language, 4GL. Some of these modern languages provide a visual or graphical interface called a visual programming environment for creating the programs. These programming languages are designed to make the computer solve a given problem without the programmer. Thus, the user does need specialized knowledge. Examples are Oracle, Python, Ruby, Prolog, etc. Language translator. To make a computer understand a program written in high-level language, it is converted into machine-level language. This is done by a translator. A translator debugs the program and helps in execution. Working of translator. Once we execute our program, source code, the translator checks the syntax of our program to make sure the programming language was used correctly. It gives all the syntax error descriptive messages. We correct the errors and rerun the program to get a no error message. The translator then translates our program into a form the computer can understand, machine code. There are two types of translators. Compiler. A compiler searches all the errors of the entire program and lists them. If the program is error-free, then it converts the code of program into machine code, and then the program can be executed. Interpreter. An interpreter translates the program into machine language line by line and checks the errors. If an error is found, it stops. Difference between compiler and interpreter. Compiler spends a lot of time analyzing and processing the program, translates it as a whole into machine code, generates the error message only after scanning the whole program. Hence, debugging is difficult. Program execution is fast. Needs more memory. Interpreter spends little time analyzing and processing the program, translates program one statement at a time, continues translating the program until the first error is met, in which case it stops. Hence, debugging is easy. Program execution is slow, needs less memory.